Okay, this is lesson 75, and we're going to first of all remember about vertical and horizontal lines. A vertical line, that's a line that goes up and down, is everywhere equidistant from the y-axis. So for example, you can see that line A here is every single point on it is always 3 to the left of the y-axis, which means that every point on there has an x-coordinate of -3. You always go -3 on every single one of those points. So that is the equation of that line. It's x equals -3 because that's the main characteristic of that line. That's all you can really say about it. Y can be anything on that line, but x is always -3 because you always go to the left 3 to get to any point on that line. That means that vertical line has the equation x equals -3, which is the opposite of what we would expect, because we usually, when we see a vertical line, we think y-axis, but that's not what we're talking about here. We're talking about what the x-coordinate is for every point on that line, and that would be -3. Same kind of thing with the other line, line B. It's always 5 away from the y-axis, so the x-coordinate for every point on that line is 5. So the equation of that line is x equals 5. All right, similarly with horizontal lines, those are lines that go left and right. Everywhere it's going to be equidistant from the x-axis. So if you look at line C, it's always 2 away from the x-axis. So you have to go 2 up to get to every point on that line, which means that the y-coordinate of every point on that line would be 2. And same thing with the other one, y equals -4. All the points on there have a y-coordinate of -4, so we say the equation of that line is y equals -4. So for vertical lines, you're always going to have an equation that just says x equals some number. And for a horizontal line, you're always going to have an equation that says y equals some other number. Now, of course, not every line is vertical or horizontal, which means we have to be able to write the equations of those lines also, and it's pretty simple to do. You just have to look for the 2 main characteristics of that line, which are the slope and the y-intercept. The slope tells how steep the line is. It's the ratio of the rise over the run as we move from point to point on the line. So from any 2 points, you go up how far and you go over how far to get from point to point. That's the rise, that's how far up you go, and the run, how far over you go to get from any point on the line to any other point on the line. And so the slope of this line is going to be 2/3. Rise of 2, run of 3 as you go from point to point. And it doesn't matter which 2 points you choose, you're always going to get 2/3 for that rise over run for this line. All right, so the y-intercept tells us where the line crosses the y-axis, and you can see it's right there at 1. So for this line, the y-intercept is 1. All right, so we can look at these 2 graphs here, and we can see that this one on the left, you can see that the line is, as you go from left to right, it's going downhill. This is just some extra stuff we need to know about the slope. This isn't exactly like your notes. Later on in your notes, you'll see a little guy driving a car on some graphs, and that's what this is about. This is about the sign of the slope. If, as you go from left to right on your graph, the line is going downhill, that means you have a negative slope. So the slope of this line would be -3/2. The rise is 3, the run is 2, but since the line goes downhill, we say that it has a slope of -3/2. Right? And then on the other line to the right, you're going uphill as you go from left to right. And so that, its slope will be positive. So a rise of 4, run of 8, so that's +4/8, or you would actually say +1/2 because you would reduce it. So downhill as you go from left to right gives you a negative slope. Uphill as you go from left to right gives you a positive slope. So once you know the slope and the y-intercept of any line, you can write its equation, because the equation of any line can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So for this line right here, you have a slope of 2/3, rise over run, and you have a y-intercept of 1. So you can write the equation of this line, y equals 2/3 x plus 1. M, the coefficient of x, is the slope, and b, the constant, is the y-intercept. So what is the slope of the line whose equation is y equals 3x minus 5? Well, look at the coefficient of x. That is the slope. It's always going to be the slope if you get your equation into this form where y is by itself on one side and everything else is on the other side. That coefficient of x is going to be your slope. So 3 is the slope on that line. And then what's the y-intercept? Just look at the constant. If you have y by itself on one side and everything else on the other side, look at the constant, and that is your y-intercept. So that y-intercept is -5. All right, so what's the y-intercept of this line? Well, that's pretty simple. It's right there, 5. That's where it crosses the y-axis. All right, so now you can use the slope and the y-intercept to graph lines. Now, you don't have to make this chart where you pick points. You can just use the slope and the y-intercept to graph lines, and that's what you need to do from now on. So you have to learn this way of doing it if you don't know it yet. All right, so step 1, the first thing you do is make sure that your equation is in the form y equals mx plus b. That means you need to have y by itself, and then you have on the other side of the equation the x term and the constant. All right, so our line is already in that form. So step 2 is to graph the y-intercept. So you look at the constant, which is 2, and you make a dot on your graph. That's the y-intercept. All right, now look at the slope. You're going to look at the rise over the run. So in this, hang on just a second, I forgot to circle the slope. So here's the slope in your equation. It's the coefficient of x. And that is what you need to figure out. Now, remember, just in case you don't know this, that when you have a negative fraction, that negative sign can be out in front of the fraction like this, or it could be in the numerator, or it could be in the denominator. You can put it in any of those places you want to. You cannot put it in both the numerator and the denominator, because if you do that, it will become positive. All right, so this is -3/5, which is the same thing as -3 over 5 or 3 over -5. So when you find, when you're using those numbers to do your rise over your run, if you wanted to use the -3 for your rise and the +5 for the run, you can do that. Or if you want to use the +3 for your rise and the -5 for the run, you can do that. So start at the y-intercept and count 3 for your rise and 5 for your run. So we're going to go -3 for our rise. So we're going to use that second fraction right here. And we're going to go +5 for our run. And so that would put us at that point. So that point is on our line. We could do the other thing. We could go up 3 and backwards 5. So up 3 and -5 to get to this point, and that would be on our line. So we have to do that when we have a negative slope. It doesn't matter whether you put the negative in the numerator, in the rise, or whether you put it in the denominator, the run. You'll get points on the line either way. And just make sure your line goes downhill if it has a negative slope, and it does. So that's the line. You just start at the y-intercept and count rise over run to get to another point, and then you can draw the line. All right, so here's another one. Graph this line. Now, this line is not in the right form. Y is not by itself. We have to have y equals mx plus b for our line. So we need to get y by itself. The first thing we can do to do that is to subtract x on both sides. And that's going to give us -2y equals -x plus 4. Now, y is still not by itself. It's got a -2 in front of it, multiplied by it. So we need to divide everything by -2 so that y will be completely by itself. So if we do that, y is going to equal 1/2 x minus 2. So now we've got it in the right form. We look at the constant, that's our y-intercept, graph that dot. Look at the x coefficient, that's our slope. So we go rise over run, 1 up, 1 up and 2 over. They're both positive, so we go in the positive direction, starting at the y-intercept, go up 1 and over 2, and put another dot. And now you've got 2 dots, 2 points determine a line, so you can go ahead and draw your line. And that's it. All right, here are 2 lines we want to write the equations of. One of them is just a horizontal line, so we know that one is just y equals -3. It's a horizontal line. It's y equals whatever that line goes through, which is -3. And then the other line, we can write y equals mx plus b. And now we have to find b. We can see pretty clearly that the y-intercept is 3. That's where the line crosses the y-axis. So that's what we put for b. And then the slope, we just start at any point on the line and we go up and over to see what the rise and the run are. So if we want to, we could just start at that point there and go up to and over -4. So we're going up to and then we're going backwards -4, because you can already see that this line is going to have a negative slope because it goes downhill. So rise over to run is 2 over -4, which is just -1/2. So that's our slope. We put that in for m, and that's it. That's our equation. Y equals mx plus b. Y equals -1/2 x plus 3. So you find the slope, you find the y-intercept, and you write your equation.